the double-slit experiment, the quantum eraser. The double-slit experiment is one of the most famous and mind-bending experiments in the history of science because it challenges our everyday understanding of reality. At its core, the experiment shows that tiny particles like electrons or photons can behave like both particles and waves. When these particles are fired one by one at a barrier with two narrow slits and then allowed to hit a screen behind it, they don't form just two simple lines as you might expect from particles. Instead, they create an interference pattern, many bright and dark bands, just like waves overlapping with each other. This strange result suggests that each particle somehow passes through both slits at the same time and interferes with itself. However, the mystery deepens when scientists try to observe which slit the particle actually goes through. The moment we measure or gain which path information, the interference pattern disappears, and the particles behave like ordinary particles again. This raises a profound question: does observation itself change reality? This is where the concept of the quantum eraser comes in. The quantum eraser experiment is a clever extension of the double-slit experiment designed to explore what really causes the interference pattern to appear or vanish. In these experiments, particles such as photons are often used, and they are entangled with partner particles. Entanglement means that the properties of one particle are deeply connected to the properties of another, no matter how far apart they are. In a quantum eraser setup, information about which path a photon takes can be marked or stored in its entangled partner. As long as this which path information exists, even if no human ever looks at it, the interference pattern disappears. This suggests that it's not human consciousness that destroys the wave behavior, but the availability of information itself. The truly shocking part of the quantum eraser experiment is that the interference pattern can be restored. If scientists later erase the which path information by making it fundamentally impossible to know which slit the particle went through, the interference pattern comes back. What makes this even more astonishing is that in some versions of the experiment, the decision to erase or keep the which path information can be made after the particle has already passed through the slits. This is known as a delayed choice quantum eraser. It seems as if the particle's past behavior depends on a future measurement, which challenges our common sense idea of cause and effect. However, it's important to understand what the quantum eraser does and does not mean. It does not allow us to send information back in time or change history in a practical sense. When scientists look at the raw data on the screen, they usually see no interference pattern at all. The interference only appears when the data is sorted or correlated with specific measurements made on the entangled partner particles. In other words, the full picture only emerges when we compare results from both sides of the experiment. This preserves the rules of causality and prevents any paradoxes like faster-than-light communication. The quantum eraser experiment teaches us a deep lesson about the nature of reality at the quantum level. It shows that quantum systems don't behave like tiny billiard balls with definite properties at all times. Instead, their behavior depends on the experimental context and on what information is available. The idea of a particle having a single well-defined path only makes sense when the experiment is set up to reveal that path. When the setup allows for multiple possibilities and no which path information exists, the system behaves like a wave. Beyond its philosophical impact, the quantum eraser has practical importance too. Understanding how information measurement and entanglement work is crucial for modern technologies such as quantum computing, quantum cryptography, and quantum communication. These technologies rely on the same strange principles demonstrated by the double-slit experiment and the quantum eraser, where information plays a central role in shaping outcomes. In the end, the double-slit experiment and the quantum eraser remind us that the universe is far stranger than it appears at first glance. Reality at the smallest scales is not fixed and independent of observation in the way we are used to. Instead, it is shaped by probabilities, relationships, and information. The quantum eraser doesn't erase reality, it erases our classical assumptions about how the world should work. If this blew your mind even a little, don't forget to like, share, and subscribe for more fascinating journeys into the mysteries of science and the universe.